This article on new inverters, very well written, by Jesse Cross. It's called Under the Skin, How New Inverters Give EVs More Power and Range. So Maclaren has a 5th generation EV inverter, which aims to improve range and efficiency. So he's saying a lot of the headlines are about EV technology relate to advances in battery technology, performance, and range. But not a lot of people talk about the inverter, which is an incredibly important middle piece between the battery and the motor itself. So the news about the EVs lately are kind of still. So we're going to be talking a lot about inverters in this episode. So the 800 volts technology is what makes rapid charging possible. So basically what the inverter does, you'll have a constant voltage from your battery pack. In order to drive a 3-phase motor, you actually need to produce a 3-phase signal. So you can't just connect your battery to the motor. It might just twitch a little bit because one coil is energized, and it'll just kind of move a little bit. But you'll have to produce voltages that change direction in order to get the rotor to actually rotate. So that's where the inverter comes in. And the inverter is basically just a bunch of switches that are controlled by a microcontroller or whatever, some kind of voltage signal. So you're hitting the gate of the transistor with a voltage, and that kind of opens it up. So now current can flow through the other 2 terminals. So if you have 4 of those, you can actually, it's called a bridge, and you can actually switch direction with 4 transistors. In order to produce 3 phases, I think the minimum amount of transistors you'll need are 6. So you have 6 switches, and I'll go over this on the drawing board in a second. And you'll be able to switch those switches in a way where one voltage source is now able to produce 3 voltage signals, 120 degrees apart, which is going to help rotate the AC motor. So in the article they're saying they're substituting silicon IGBTs, so insulated gate bipolar transistors, for silicon carbide MOSFETs. So that they're a little bit different in their physics, but still have the same mode of or type of operation. So in the MOSFET it's very similar. You'll have different regions of silicon sandwiched between, it's like a silicon sandwich, and you can dope one part of the silicon sandwich to a polarity of your choice. So you can inject it with a bunch of atoms that have one excess electron or one fewer electrons in order to produce holes or a negatively charged region. So what makes this so powerful is that you can apply a voltage on the gate, which is going to suck charges from one region to the other and produce this kind of little bridge where charges can flow through. So that's kind of the operation of the MOSFET. The IGBT is very similar. That's kind of the basic understanding of the physics of MOSFET and an IGBT. But basically what these are just high-tech switches that are voltage controlled. And what makes that so powerful is that a microcontroller can switch these as you wish and at whatever frequency you want. So the silicon carbide MOSFETs can switch current faster and handle more power. It says here, so the HPI 800 can switch at 40 kilohertz. Is that fast? So let's think about it. You have a motor, and how fast do you want that motor to spin? If you have a gearbox, then 40 kilohertz should be more than enough, right? So the silicon carbide MOSFETs have been able to, they can switch faster, they can handle more power, and it helps increase the power to weight ratio. So you'll have 54 brake horsepower per kilogram to 134 per kilogram. So the car becomes lighter. So NIO's silicon carbide inverter was developed by its motor division, Igbt, and it will be launched in the ET7 later this year. The NIO claims the switching losses are reduced by more than 30%. That's great. And then the Maclaren's applied IPG5 inverter can drive motors with a peak power of 469 brake horsepower. It weighs about 5.5 kilograms and occupies a space of around 3.79 liters. What's that, a gallon? The new inverter is going to make its debut in the King's M Hyper GT. Let's just take a look at that car. Oh wow, okay. Kingdom Hybrid Hypercar project is going to have the Maclaren inverter in it. So it's not just about the battery technology, a lot of it is the inverter, the power that the inverter can handle. So I'm glad this article kind of talks about this sometimes neglected component of the EV drivetrain. But this little box is super important. It's what enables a battery to run a AC motor. So let's take a look at Polestar's manufacturing process. There's a new bonded aluminum platform. It's lighter, a little bit faster to manufacture than the previous methods. They're developing the body and the platform in unison. So this is all to increase power, reduce weight, improve efficiency. So yeah, so let's jump over to the drawing board for a second. Okay, so this is a simple circuit. We have 4 transistors connected in the bridge formation. And we have the battery pack right here. So once we hook up the battery pack to this circuit, we tell the microcontroller to activate these 2. So if these 2 are activated, current is going to flow this way. And I'm going to use the blue pen for the other direction. So now we tell the microcontroller to activate these 2. Can you see how current is now going through the opposite direction? Let's try and draw it one more time with these 2 again. Now current goes through this way. Let me draw it half finished, so that might make it even easier. Okay, so this is one direction. This is going to be the other. Okay, this might make it a little bit clearer. So when you're activating this one and this one, current's going to hit this way first. If you activate this one and this one, current is going to go through this way. So that's a simple inverter bridge. Let's take a look at a 3-phase. Okay, so now you have your phase 1, phase 2, phase 3 here. And you just connect this to any kind of load. So let's say the motor is in a delta. Yeah, you just hook up the phases, just like that. And let's say you're running a Y load. Same thing. Just hook up the phases like this. Boom, there you go. Your motor is going to turn. And this is kind of the technology that by switching up these ones to better performing transistors, you have more power. More power means higher voltage, which means rapid, faster charging. And yeah, you can draw the microcontroller here. I guess this is kind of what it would look like at a PCB. And this is the MCU, the microcontroller unit. Alright, yeah, I mean, this is a lot to take in. This is kind of just a brief overview of what the inverter does and kind of how it works. It's basically just a bunch of switches connected in an array. A microcontroller controls when and how it's switching. And the microcontroller operates at a very fast speed. Let's say you're just using 100 megahertz for your microcontroller. That's fast enough so they said one inverter was at 40 kilohertz. So any microcontroller is going to be able to keep up with at least the gate voltages and the speed. So basically, if you switch these faster, this is going to rotate faster. That's kind of the switching speed that they were talking about in the article. Alright, thank you. This was a very inverter based episode. So yeah, we just kept it at the inverter level this time. Hopefully you learned something. Yeah, thank you. Thank you for watching. Stay safe. I'll see you in the next episode.